Hello everyone, welcome back to my YouTube channel. If you still haven't subscribed my channel, जल्दी से जाके पहले सब्सक्राइब कर लीजिए and like my video. और ये वीडियो को देखने के बाद whatever your views are, आपको ये वीडियो बहुत अच्छी लगी, आपको ये वीडियो में कुछ लगा कि मैम ये वाली चीज नहीं समझ आई, I have some doubts, then do comment in the comment section. I will be more than happy to answer all your queries. Okay. So now, without wasting any time, let's start with the video. So in this video, as you have seen, I have written a problem. In the today's lecture, I will be solving some more questions on, using the Coulomb's law, and these questions are very important. इससे पहले की जो videos थी, उन videos में जो हमने problems किए थे, they were on the easier side. But अब जो हम लोग questions करने वाले हैं, I will be taking some good questions जिसके अंदर they will be challenging your concepts. So without wasting any time, let's start with the question. So the question number one that I'll be doing today is, let's read the question together. So we have two electric charges. A charge is Q and 2Q, and they are kept at a distance D from each other. So from this line, I know that I have a charge Q, I have a charge 2Q, and they are kept D distance away from each other. So this is the line joining the two charges, and Q and 2Q are D distance apart. A third charge Q is placed along the same line. So I have placed a third Q charge along the same line in such a way. So I'm putting the charge capital Q in such a way that the net force on Q and 2Q is 0. So that means the net force on Q is equal to 0, and similarly the net force on 2Q is equal to 0. So now let us see from this what do we get, and this from this what do we understand. Okay, so let's first always सबसे पहले आपको क्या करना है, आपको सबसे पहले देखना है कि what are the forces which are acting in the system, right? तो अगर मैं स्मॉल क्यू चार्ज को देखती हूँ, तो ये अगर मैं इस स्मॉल क्यू चार्ज को देखूं, सब इस स्मॉल क्यू चार्ज को देखेंगे, इस स्मॉल क्यू चार्ज को जब मैं देखती हूँ तो मुझे पता है कि इसके ऊपर ये कैपिटल क्यू का चार्ज है और ये 2Q का चार्ज है जो फोर्स लगाएगा, राइट? अब क्या small q and 2Q charge, they have the same sign. So 2Q charge will repel the Q charge. So 2Q charge is pushing the charge away, right? So this is the force due to small 2Q charge. And I have been given that the net force on Q is equal to 0. What does this mean? This means कि अगर 2Q charge एक डायरेक्शन में फोर्स लगा रहा है, तो जो कैपिटल Q चार्ज है उसको इक्वल एंड ऑपोजिट फोर्स ऑपोजिट डायरेक्शन में लगाना पड़ेगा, ताकि जो नेट फोर्स है Q चार्ज पर वो 0 हो जाए. इजी, राइट? एंड सिमिलरली अगर नेट फोर्स ऑन 2Q को 0 करना है, तो 2Q चार्ज पर जो फोर्स एक्सर्ट कर रहा है Q चार्ज, उसका ऑपोजिट फोर्स एक्सर्ट करना पड़ेगा कैपिटल Q चार्ज को, तभी नेट फोर्स 0 होगा, है ना? So let me call this equation number 1 and this as equation number 2. So from equation number 1, I can write that F due to small 2Q charge has the same magnitude as the F due to capital Q charge, right? Easy to understand. अब F due to 2Q charge, what will that be? That will be K. This is being exerted on the Q charge. Then I have 2Q, and what is the distance between Q and 2Q? It is D. So we have D square, and F due to capital Q. So similarly, K, Q, capital Q divided by what is the distance between Q and capital Q charge? It is X square. So I am assuming that I have put the Q charge X distance away from the small Q charge, and this distance will then become D minus X. This distance will then become D minus X. Okay. So let us see इससे मुझे क्या मिलता है. Okay. So this K and this K gets cancelled. This small q and this small q gets cancelled, and I get that 2Q by D square is equal to capital Q by X square. इसको हम लोग square में, cloud में, whatever, you just have to remember कि this is the equation that I am getting. Okay. इसको ध्यान रखना है, इसको बॉक्स में लिख लेना है ताकि हमें कंफ्यूजन ना हो जब हम आंसर सॉल्व करने कि हमने इक्वेशन निकाली क्या थी। फाइन। अब हम लोग सेकेंड इक्वेशन का यूज करते हैं। सेकेंड इक्वेशन बोलती है दैट एफ ड्यू टू स्मॉल क्यू चार्ज उसका मैग्नीट्यूड शुड बी इक्वल टू मैग्नीट्यूड ऑफ द फोर्स ड्यू टू कैपिटल क्यू चार्ज, राइट? ओके, सो के this force is being applied on 2q charge by q divided by what? Divided by what is the distance between 2q and q? It is again d square. And in the right hand side, what we will have? We will have k applied on 2q by capital Q. And what is the distance between capital Q and the 2q charge? It is d minus x, right? It is d minus x whole square. Now, if I simplify this, I will get k, q, k and q. This all gets cancelled and I am left with 2q divided by d square is equal to 2q divided by d minus x raised to power 2. Okay, so this is what I am left with. Now, इसको भी what I do, I put it in a cloud. इसको भी मैं एक cloud में लिख लेती हूँ, cloud में रख लेती हूँ. Now, okay, let me write this answer. So आपको पता चल जाएगा कि यहाँ से answer start हो रहा है, right? So I have now the equation number 1, which is 2q by d square. ये मेरी equation number 1 है और ये मेरी equation number 2 है. ठीक है? अब दोनों के लेफ्ट हैंड साइड में 2q by d square है, दोनों के लेफ्ट हैंड साइड में 2q by d square है. So can I equate these two equations? अगर दोनों का लेफ्ट हैंड साइड सेम है तो मैं RHS को दोनों के इक्वल रख सकती हूँ, राइट? सो आई कैन राइट दैट q by x square is equal to 2q by d minus x whole square, right? I can write this, okay? By equating the equation number 1 and equation 2. Why did we equate? क्योंकि दोनों का left hand side was same. Now, this q and this q gets cancelled and I can write that d minus x by x whole square is equal to 2. I can write this. Now, d minus x by x will become plus minus root 2, right? And d minus x is equal to plus minus root 2x. So, d becomes x plus minus root 2x. D is equal to, I take x common, plus 1 plus minus root 2 and x from here becomes d upon 1 plus minus root 2. Okay. So the question was asking, calculate the position of the charge q. So for calculating the position of the charge q, this is the position of your charge q. This is the position of your charge q. Now what do you have to do? Net force also calculate the position of the charge q. So this is what you were told to find, and this is your answer. Okay. Now, if the question asks you find the value of q in terms of small q, if the question comes like this, okay, so this is something which I'm telling you an extra point that ऐसा भी हो सकता है that they ask you कि आपने जो कैपिटल Q रखा है उसको स्मॉल q के टर्म्स में लिखिए. तो उसके लिए आप क्या करेंगे? उसके लिए आप क्या कर सकते हो? आपके पास जो ये इक्वेशन है, ये इक्वेशन नंबर 1 है, ये आपकी इक्वेशन नंबर 2 है. इस इक्वेशन 1 और इक्वेशन 2 में जो भी आपको आसान लग रही है, विच एवर इज योर फेवरेट, जो आपको लगता है आप आसान से सॉल्व कर लोगे, उस वाली इक्वेशन में इस वाले एक्सप्रेशन को सब्स्टिट्यूट कर दीजिए. ठीक है? ये जो आपका x इज इक्वल टू डी अपॉन 1 प्लस माइनस रूट 2 है, इन दोनों इक्वेशन में से 1 और 2 में से किसी भी एक इक्वेशन में आप उसको सब्स्टिट्यूट कर दीजिए एक्सप्रेशन को, और वहां से आपके पास क्या आ जाएगा? कैपिटल Q इन टर्म्स ऑफ स्मॉल q आ जाएगा. ठीक है? आई होप आपको ये वाला क्वेश्चन अच्छे से समझ आ गया हो. ठीक है? आ गया समझ सबको? आई होप जिसने खुद से ट्राई करा करने का उससे भी ये क्वेश्चन हो गया हो. अगर नहीं हुआ हो तो डेफिनेटली आप वीडियो को देखिए और समझिए और इसको रिवाइज करके एक बार बिना सॉल्यूशन देखे इसको लिखने की कोशिश करिए. ओके ओके, so let's move on to another question. Now these kinds of questions you will see a lot of times in your board exams. Okay, so let me write the question. So the question is that find the total force on charge placed at point C. Okay, so you have to find the total force on the charge which is placed at point C, and the figure for this question is that I have a triangle A, B, and C, something like this. Okay, give me a second. Yeah. So I have three charges which are placed at the three corners of the triangle. Okay. So पहले के ऊपर जो आपका चार्ज है, A पर जो चार्ज बैठा है, that is 2 म्यू कूलम. जो B पर बैठा है, that is also 2 म्यू कूलम. और C के ऊपर जो आपका चार्ज बैठा है, that is 3 म्यू कूलम. Okay. So you have three charges which are sitting at the corners of a triangle, and it is given that जो आपका ये साइड है, yeah, so I want the diagrams to be neat. So it is given to you that this is 3 meter. Let me call this O. This is 3 meters and this is 4 meters. Okay. And you have to find what is the total force on the charge placed at point C. तो point C पे कौन सा चार्ज है? 3 म्यू कूलम. ये चार्ज है ना. आपको बताना है इसके ऊपर कितना फोर्स लग रहा है. फाइन. अब यहां से मुझे दिख रहा है, आई कैन सी दैट 3, 4 and this is a 90-degree angle. This is a right angle, right? So I know 3, 4 and 5 are my triplets, right? इनको हम लोग क्या बोलते हैं? पाइथागोरस ट्रिपलेट्स बोलते हैं ना. तो यानी कि 3 square plus 4 square is equal to 5 square. So what is the length of the AC? What will be the length of AC? That will be 5 meters. Similarly, the length of BC would also be 5 meters. Okay. So now I have the two lengths and I want to calculate the force. So let us see what will be the direction of forces. So अगर A 2 म्यू कूलम है and C 3 म्यू कूलम है, both are positively charged. So what will be the direction of the force because of A on C? It will be along this line and away from the charge. It will be along this line and away from the charge, right? Similarly, B point को देखेंगे. B point पे you have a positive charge and C point पे you have a positive charge. So what will be the direction of the force? Let me erase this. इसको हटा देते हैं एक सेकंड के लिए. So it will be along this line in the opposite direction. It will be along this line in the opposite direction, right? So now, if I have to, so I have to write force on C due to A and force on C due to B. और F जो है वो क्या है? एक वेक्टर क्वांटिटी है, तो आपको एक ऊपर एरो लगाना पड़ेगा, right? Easy? Okay. So now what do you have to do? Now what do you have to do? आपको बताना है, what do you have to tell? मैं यहाँ लिख लेती हूँ कि C पर जो चार्ज है that is 3 म्यू कूलम. आपको बताना है what is the total force on charge C. ठीक है. तो that is F total. तो जो आपका F total है that is actually the vector sum of FCB and FCA, right? It is the vector sum of FCB and FCA. So if it is the vector sum of FCB and FCA, how will I add them? Right? मैं उसको add कैसे करूंगी? So one thing you can do is आप दोनों का मैग्नीट्यूड निकालो एंड आप ट्रायंगल लॉ लगाओ. ठीक है. आप ट्रायंगल लॉ लगाओ और उससे सॉल्व करो. बट दैट इज अ लिटिल लेंथी मेथड, राइट? वो थोड़ा एक लेंथी मेथड है. लेट अस सी हम इसको और कैसे अच्छे से सॉल्व कर सकते हैं बाय रिजॉल्विंग द वेक्टर्स, राइट? बाय रिजॉल्विंग द वेक्टर्स. तो क्लास 11th और 12th में आपने क्लास 11th में आपने रिजॉल्विंग वेक्टर्स सीखा है. तो वो हम कैसे करेंगे हम देखते हैं. that since इस triangle की AC side is equal to the BC side, then this angle, if I call this angle theta, I can say this angle is also theta, right? If I call angle BAC as theta, I can say that angle ABC is also theta. If both the angles are theta, and if I draw a perpendicular over here like this and a perpendicular over here like this, then what will be this angle? This angle will be 90 minus theta, right? This will be 90 minus theta. If this is 90 minus theta, this angle will be theta. This angle will be theta. And I know if this angle is theta, then this angle is also theta. This angle is also theta. And by similarity I can write, क्योंकि मुझे पता है ये जो है ABC, ये वाला एंगल भी थीटा है. Okay, let me use laser ताकि आपको समझ आ जाए. Yeah, okay, since ये वाला एंगल थीटा था, तो उससे ये वाला एंगल थीटा आ गया. अगर ये वाला एंगल थीटा है, तो उससे मैं लिख सकती हूँ कि ये वाला एंगल भी थीटा होगा, है ना? आई कैन राइट दिस. तो मुझे ये कैलकुलेट करने की जरूरत नहीं है. मैं ये लिख सकती हूँ कि जो ये वाला एंगल है वो भी क्या है, वो भी थीटा है. ठीक है, वो वाला एंगल भी थीटा है. अब थीटा जो है वो हॉरिजॉन्टल डायरेक्शन किसके साथ, मतलब जो आपका वेक्टर है उसकी हॉरिजॉन्टल डायरेक्शन क्या होगी, ये होगी. इसके अलोंग वो कैसे ओपन होगा, इट विल बी एफ कॉस थीटा, राइट? इट विल बी एफ कॉस थीटा. और मैं इस यहाँ पे जो वर्ड ऐसे जा रहा है उसको मैं बोल सकती हूँ एफ साइन थीटा. उसको मैं बोल सकती हूँ एफ साइन थीटा. Let me take another pen. So what I'm saying, मैं इस फोर्स को, जो यहाँ पे ये वाला फोर्स है, इस फोर्स को मैं रिजॉल्व कर रही हूँ दो पार्ट्स में. एक है इस डायरेक्शन में, और क्योंकि जो ये फोर्स है वो इस डायरेक्शन के साथ थीटा एंगल बना रही है, इसको मैं बोलूंगी एफ कॉस थीटा. और जब मैं इसको इस डायरेक्शन में लिखूंगी तो उसको मैं क्या बोलूंगी, एफ साइन थीटा. सिमिलरली जो ये वाला फोर्स है वो इस डायरेक्शन के साथ थीटा एंगल बना रहा है, तो मैं इस फोर्स को जब रिजॉल्व करूंगी तो ये हो जाएगा एफ कॉस थीटा. और इस डायरेक्शन में जब मैं इसको लिखूंगी तो दैट विल बी एफ साइन थीटा. ओके, सो नाउ I know let me see first what is the magnitude of force CB. So the magnitude of force CB, let us calculate the magnitude of force CB. So that is the force on C due to B. What is the force on C due to B? So it will be K. Charge on C is 3 mu C. Charge on B is 2 mu C. And the distance between them is 5 square. And what is the magnitude of force on C due to A? तो अगर आप इसको लिखोगे that will be K 3 mu coulomb 2 mu coulomb by 5 square. So are these two forces equal? Are these two forces equal? Are the magnitude of these two forces equal? So if the magnitude of two forces is equal, then will. Now you will answer this yourself. Will this f cos theta, which I have written over here, and this f cos theta balance each other? क्या ये एक दूसरे को बैलेंस करेंगे? The f cos theta will get cancelled, right? क्योंकि अगर मैं ऊपर की डायरेक्शन में f cos theta लगा रही हूँ और नीचे की डायरेक्शन में भी f cos theta लगा रही हूँ, so what will happen? They will nullify each other. They will cancel each other. And the net force in this direction, upward and downward direction में जो net force है, that will become 0. So I can write that the f cos theta in the upward and the downward direction will balance each other. they will balance each other. ठीक है? तो upward और downward direction में जो forces है, they are balancing each other. And जो force है in the right direction, right? जो इस direction में force लग रहा है, that is F sin theta and F sin theta. Both the forces are in which direction? Are in the same direction. So they will get added. They will get added. If two vectors are in the same direction, उनका addition directly algebraic तरीके से आप कर सकते हो, है ना? So the net force in the direction, in the horizontal direction, is equal to F sin theta plus F sin theta, which is equal to 2F sin theta. I had already calculated the value of F. दोनों F की वैल्यू सेम है, तो लेट अस पुट दिस वैल्यू. आई हैव 2 तो बाहर है, अंदर क्या आ जाएगा? K. I had 2 mu coulomb, 3 mu coulomb by 5 meters square. This was the force. And now I want the value of sin theta. तो अभी sin theta की वैल्यू क्या होगी? अब जो समझदार बच्चे हैं वो कहेंगे मैम sin theta क्या होता है? Perpendicular upon hypotenuse. So what was the theta that we assumed? The theta that we assumed was this, right? तो अगर ये थीटा है, तो अगर मैं किसको देखूं? अगर मैं ट्रायंगल AOC को देखूं, सारे ट्रायंगल AOC को देखेंगे. कौन से ट्रायंगल को देखेंगे? AOC ट्रायंगल को देखेंगे. इस ट्रायंगल में अगर ये एंगल थीटा है, then which is the direction which is perpendicular? Which is the perpendicular direction? This is my perpendicular direction and this is my hypotenuse. So I can write that sin theta is equal to perpendicular upon hypotenuse. Perpendicular is 4 meters, hypotenuse is 5 meters. So sin theta is equal to 4 by 5. Sin theta is equal to 4 by 5. तो यहाँ पे हम लोग sin theta की वैल्यू क्या पुट कर देंगे? We will put sin theta is equal to 4 by 5. And now we have to simplify. Now we have to simplify this value. And how will we simplify it? We know that we have a 2 over here. What is the value of K in SI units? It is 9 into 10 raised to power 9. I have 2. When you have mu coulomb, what does that mean? That means that it is equal to 10 raised to power minus 6 coulomb, right? It is 10 raised to power minus 6. Mu का मतलब होता है 10 raised to power minus 6. So I have 10 raised to power minus 6. Then we have 3. Then we have another 10 raised to power minus 6 divided by 25 into 4 by 5. Okay. So this is your answer. And when you will solve this, you will get your answer, which is equal to 3.4 into 10 raised to power minus 3 Newton. Okay. And it is along which direction? It is in the horizontal direction away from both the charges. जो यहाँ पे दो charges हैं A and B, इनसे दूर जा रहा है force और it is in this direction. The net force is in this direction. Okay, so net force is in this direction. तो आप एक छोटा सा डायग्राम ड्रॉ करके दिखा सकते हो कि जो आपका net force है वो इस direction. Okay, and what is the direction of the, and what is the magnitude of the net force? The magnitude of net force, when you will calculate, it will be 3.4 into 10 raised to power minus 3 Newton. So this is your solution of the question. Now I will be writing another question, and this will be your homework question. I will not be doing this question for you all. I am providing you a homework question. I will discuss this question in the next video. So I hope you all try this, try to solve it. And if you have any problems, then you can definitely see my next video and I'll be solving this question for you in that video. Okay, so you have a system like this. I have 3 charges. Okay, I have 3 charges. So this is C point, this is B point, and this is A point. and the three charges are minus 10 mu coulomb, which is kept at C point. I have a plus 10 mu coulomb, which is kept at B point, and I have a plus 5 mu coulomb, which is kept at the A point. And what you have to do, you have to find the resultant force. Okay, so you have to find the resultant force on charge A, on charge kept at point A of an equilateral triangle with side 5 meters. So you have an equilateral triangle जिसकी sides जो हैं are 5 meters. Okay, so let's change this. Let's make this question. You can write that आपको यूनिट्स से डील करना आना चाहिए, तो इस मीटर को हटा के हम लोग यहाँ लिख देते हैं सेंटीमीटर. सो यू हैव अ ट्राइंगल जिसका साइड इज 5 सेंटीमीटर, उसके तीन एज कॉर्नर्स पे आपके पास तीन चार्जेस पड़े हैं, एंड यू हैव टू फाइंड व्हाट इज द नेट फोर्स, व्हाट इज द रिजल्टेंट फोर्स ऑन द चार्ज व्हिच इज केप्ट एट ए पॉइंट. ठीक है, सो दिस इज योर होमवर्क क्वेश्चन. लेट मी कंप्लीट द फिगर. So this is the triangle, and the side, each side is 5 centimeter, not meter. 5 centimeter. I am giving you the conversions that 5 centimeter is equal to 5 into 10 raised to power minus 2 meters. So this will help you. Okay, if you do not know the conversions, these conversions will help you. And 5 mu coulomb will be 5 into 10 raised to power minus 6 coulomb. So basically that means that 1 mu coulomb is equal to 10 raised to power minus 6 coulomb. Okay, so these are the conversions that will help you all. Try to solve this question, and all the best. And thank you so much for watching this video. If you have any doubts, feel free to ask me in the comment section. If you liked my video, please do like this video and share this with your friends. Thank you so much, everyone, once again. Bye bye.